What if everything, every particle, every atom, every beam of light, isn't made of things at all, but of vibrations in invisible fields that fill the entire universe? What if reality itself is a symphony of energy, and matter is just the music it plays? That's the vision behind one of the most profound ideas in modern science, quantum field theory, or QFT, the ultimate framework that unites quantum mechanics, special relativity, and the deep structure of matter and energy. Welcome to the Learning Studio, and in today's episode from our physics playlist, we'll explore quantum field theory, the theory that changed our understanding of existence itself and continues to inspire modern AI physics simulations and computational models that predict the unseen. You can watch the complete physics playlist by clicking the link below in the description. This episode is part of our new section, Quantum and Relativistic Revolution, where physics meets computation. Here, we step into the frontier where mathematics, data, and reality converge. From particles to fields, the quantum revolution. For centuries, physics treated particles as tiny, solid points moving through empty space, from Newton's apples to Bohr's electrons. But as experiments grew more precise, the picture began to shift. When scientists observed electrons in particle accelerators, they didn't behave like tiny balls, they acted like waves, spreading across space. Yet when measured, they appeared as discrete particles. This duality, being both a wave and a particle, puzzled physicists for decades, until a new idea emerged. What if particles are not things at all, but excitations in a field? In other words, just as a ripple moves through water, a particle is a ripple in a quantum field. The electron field, photon field, quark field, each fills all of space, constantly fluctuating, interacting, and exchanging energy. This was the birth of quantum field theory, the idea that everything in the universe is built from vibrating fields of energy. Fields, forces, and the fabric of reality. QFT unifies all known forces, except gravity, under a single mathematical language. Every interaction, every force, every transformation between particles happens because fields interact, exchanging quanta, the smallest packets of energy. When two electrons repel each other, they do so by exchanging photons, ripples in the electromagnetic field. Inside the Sun, quarks exchange gluons, ripples in the strong nuclear field, to bind protons and neutrons together. Even empty space isn't truly empty, it's a quantum vacuum, teeming with energy fluctuations, where particles can pop in and out of existence. This is where Einstein's relativity meets quantum mechanics, showing that space, time, and energy are deeply interconnected. In QFT, reality is not made of matter sitting in space, reality is the fields themselves, constantly moving, vibrating, and evolving. Mathematics beyond the visible. Quantum field theory is not just a physical theory, it's a masterpiece of mathematics. It combines differential equations, complex analysis, and probability amplitudes to describe how fields interact at the tiniest scales. One of its greatest triumphs is the Standard Model of particle physics, which describes all known particles and three of the four fundamental forces: electromagnetic, weak, and strong. It's one of the most accurate scientific models ever built, so precise that its predictions have been confirmed to 12 decimal places. And yet, QFT also leaves us with questions about dark matter, dark energy, and gravity, which still resists full unification. These mysteries continue to drive new physics and new computational exploration. QFT meets AI, the computational frontier. Today, physicists and computer scientists are using AI and machine learning to simulate QFT systems that were once too complex for traditional computation. Quantum fields generate enormous datasets of probabilities, countless possible states and interactions. AI models can now analyze these patterns, predict new particle behaviors, and accelerate discoveries in quantum materials, fusion research, and high-energy physics. Even neural networks themselves are beginning to take inspiration from QFT, where information, like energy, flows through interconnected fields of artificial neurons. In a way, AI systems are starting to mimic the universe's own design, layers of dynamic, interacting energy patterns. The deeper meaning of fields. Quantum field theory shows us that what we call solid reality is actually a restless ocean of invisible energy. Every atom, every photon, every breath you take is a localized vibration in an infinite, interconnected field. It's a vision of the universe not as a collection of objects, but as a living web of motion, resonance, and probability. A universe that doesn't just exist, but computes itself through interactions of energy and information. This is the Learning Studio, and this was our episode on quantum field theory, QFT. If you were fascinated by this glimpse into the deep structure of the universe, make sure to subscribe, like, and check out the physics playlist linked below. In our next episode, we'll journey into the strange and beautiful world of quantum entanglement and information theory, where particles communicate across space, and the universe itself begins to look like a cosmic computer. Because in physics, the more we zoom in on reality, the more we realize it's made of possibilities, not particles.